Hi and welcome back. This time we will be solving a similar question, a similar problem that we have solved in the most recent video. It's dynamics number 5. So this is dynamics number 6. So we will be solving a similar question. The only difference is, if you notice, the angle, okay, the angle of the force that is being applied on the block is measured from the vertical axis or from the y-axis. So earlier it was measured from the x-axis, but this time it's measured from the y-axis. So what is the difference when we are measuring an angle from the y-axis? What is the effect in our solution? Okay, so if you notice, we have the same requirements in the question. We are going to be solving for the coefficient of friction. Okay. Since the initial condition, it's not moving, and then the final condition, it's still not moving, so there's no change in motion. And in this case, it's static, it's not moving. So we are supposed to be solving for the coefficient of static friction. The coefficient of static friction, okay, so the coefficient of static friction for this problem, what if it's measured from the angle is measured from the y-axis or the vertical axis? Also, we are going to be solving for F. And again, same state of motion. There's no change in motion or state in motion. There's no change in rate if it's moving at a v meters per second or 0 speed, the direction is to the right and it's still to the right, then the acceleration is 0. So we can write it here, acceleration. So let's analyze the acceleration. The acceleration along the y-axis, the acceleration along x-axis. So let's take a look at the motion. The acceleration along the x-axis or y-axis, since it is being dragged along the horizontal surface, okay, the block is being dragged, but it doesn't mean that it's moving. It's being dragged along the horizontal axis, so there's no motion along the y-axis. And also, we all know that since velocities are 0, so we can say that the acceleration along the x-axis is also 0. So acceleration on both axes is 0. Just like what we've been doing in the past, and same process of solving this problem, we will start with the free body diagram. So let me just write it here. Free body diagram, FBD. So let's start with a free body diagram. So assuming that there is an imaginary x and y coordinates right here. Okay. So we have our imaginary dot along the intersect of the x and y coordinates, x and y axis. Imaginary x and y axis. So let us draw it here. Let's put our dot right here. Okay. So again, I think you have the idea. First force is always force due to gravity, because every object on the surface of the earth or any matter would have mass, and mass would result into weight or force of gravity. Again, from the previous question, you would know that I will not draw normal force. Okay, that is the same length of our FG. Even though I know it's not moving, they're supposed to be balanced because of the force that is applied is not along the axis. So therefore, we must consider the force that is part of the component of the force along the vertical axis. So let me just draw the applied force F right here. Okay. And that is your F. And if you notice, I did not draw my angle, because in your free body diagram, it's only the actual forces that's being applied. Again, because the force is right here, is, or the velocity is 0, so we must consider this force of friction as static friction because it's not moving. Now, if you're not sure, just leave it as FF. Okay, and then you will figure out later, oh, it's not moving, so therefore it should be static friction. First step, so this is for the person grading your work. Just leave it as is. That will be your solution. Okay, don't add any more information. Do not add additional information because you don't need additional information for our for that free body diagram. Now, let's continue with our solution. At this point, okay, so if you notice, just like what I did with dynamic video number 5, okay, what I'm gonna do is just redraw the dot right here, and I will have my force going down as my force of gravity. That is mass times G. Okay, so mass times G, that's your force of gravity. And then our normal force. And then let's draw our coefficient or force of friction, to be exact, static friction. And this is our applied force. Okay, so this is the applied force. Okay, so applied force. Now, where is the angle? Where did we measure the angle? Earlier, the angle was measured here, but this time the angle is measured over here. Okay, so it's measured along the x-axis. So it's measured along the x-axis. So what I'm gonna do, okay, is to draw a triangle that would form that angle. Okay, let me just draw those dots so we figure out the different components. Again, this one is your x component, and this is the red one is your y component. So this is your force along your y component. So the difference earlier is that if I may bring out our previous solution, it was drawn this way earlier. Now it is drawn from the x-axis, or from the y-axis. The angle is measured from it. Okay, so measured from this one right here, or from this. So the opening is right there. So now we have our triangle right here. We have our triangle. So what function can we use for fx? Okay, so let's use, okay, so let us use a different trigonometry function. So let's put it here. Let's say if I have my sine, okay, sine theta, so if I have my sine theta, and if I have my cosine theta, and from this illustration, your hypotenuse is your f. So let me just put it here, over f. Okay, so we should divide it by f. So which one should be our numerator? Okay, so if this is the angle, sine means opposite over hypotenuse. What is the opposite side here? Is it your y-axis, the y component, or the x component? For sure you would say, oh, that's the opposite side. It's opposing on the opposite side of our angle, so that's your fx. So x becomes sine. And over here, your y component becomes part of the cosine function. Now, if I am going to simplify this further, Now I can say that my fx is simply my f, but this time instead of cosine theta, it's sine theta. Likewise with our y component, that would be f cosine theta. In the previous solution that we worked on, x is cosine, but this time it will be sine. Y is sine, but this time it's cosine. So you change it depending on where you measure the angle. Again, if you measure the angle from your horizontal axis or from your x-axis, then your answer, then your x component will be cosine, your y component will be sine. But if you measure it from the vertical axis, then all you have to do is flip the function and just follow the same process that we've been doing in order to come up with the answer. So that's all we need to do. Switch the function if the angle is measured from x to y or y to x axis. Now, let me just finalize my last part of my free body diagram. So I would have my FG again. So my FG is mass times G. And I have my normal force, which is Fn. I have my force of static friction, which is mu s times normal force. And then we have those two different forces or two additional forces that is acting. First one, I have my f of x, which is f of sine theta. Okay, don't get confused. This time it's sine because it is measured from the y-axis. And then we have our fy, which is f of cosine theta. So let me just pause so that you can catch up. Yeah, trying to understand it. You can always pause it and then come back. And for those of you who have not subscribed, yes, you may subscribe. So you would receive notification in case there are some additional problems based on some questions that you have requested me to show you some solutions. Okay. So here we go. So at this point, let us work on the y components. So summation of forces along the y-axis is equivalent to mass multiplied by the acceleration along y-axis. We're positive going up, negative going down. So let's take a look at these forces. So it's similar to what we have earlier. So we have our y component going up. So let's start with the normal force minus or plus your f sub y minus f of g multiplied by mass and the acceleration of 0. F of n plus what is your cosine this time, what is your y component, so this time it's cosine, so f cosine theta minus mg equals 0. Now we will be needing Fn to solve for coefficient of friction, so let us move the other components to the other side of the equation, leaving Fn on one side of the equation. So if I will write F sub n, the normal force, this is negative, you move it to the other side of the equation, changing it to positive mg minus F cosine theta. So earlier in the previous video, it is F sine theta instead of cosine theta. But since we are measuring it from along the y-axis, so be careful. Sometimes it does make a difference in terms of your solutions. So this is your first step. The second step is work on the summation of forces along the x-axis is equivalent to mass multiplied by the acceleration along x, and we all know the acceleration along x is also 0. Forces to the right is positive, to the left is negative. So let's have F sub x, or the components of the force applied along the x-axis, minus the force of friction, static friction to be exact, is equivalent to mass multiplied by the acceleration, that is 0. So that will give us F of x is F sine theta. Again, now this time it's sine theta minus mu s, and that is F of n equals 0. Now I want to solve for my coefficient of static friction for letter A. So I will keep my coefficient of static friction on one side of the equation. So if I move it to the other side, that will give us positive. So mu s Fn, okay, some of you might want to see it, so that's negative, and then I bring this to the other side, which is negative F sine theta, because I know I simply just put it as positive earlier, so I will show it to you. So now we have mu s is simply equivalent to negative F sine theta divided by negative mu, or coefficient of static friction. That will cancel out the positive sign, the negative sign, so leaving it positive. Well, this is not mu s but Fn, I'm sorry. So this is F normal force, Fn, so normal force. So that's your normal force. Getting too excited again. So the coefficient of static friction is simply equivalent to normal force. And what is your normal force? That is mg minus F cosine theta. So simply mg minus F cosine theta, and then let's have our F sine theta right here. So this will be our answer to letter A. So this time sine is on the top, cosine is on the bottom. Unlike in the previous video, cosine is on the top, sine is on the bottom. So that's the difference between those two solutions. So again, following the same step that we did last time, so we will use this again in order to solve for F. So let's write it down. Which is F sine theta minus mu, or the coefficient of static friction, multiplied by the normal force equals 0. But we also know that the normal force is simply equivalent to mg F cosine theta. So let's plug in that value. So I will try to write smaller, but let me just zoom it in so you could see. So F sine theta minus mu s, that's Fn, so this will give us mg minus F cosine theta equals 0. Okay, distribute the value of mu s. Let me try to write a little bit smaller so it could fit. Sine theta minus mu s mg positive F cosine mu, okay, coefficient of static friction mu s F cosine theta equals 0. Now let's combine all the coefficient with the same variables. Okay, put all the same variables on one side of the equation. So what I'm going to do is have all my f's. So f sine theta plus mu s f cosine theta. And then let's use the other side of the equation to write our, from negative, it changed into positive. So mu s mg. Okay, so let's factor out f on one side of the equation. So let's have f sine theta plus mu s, or coefficient of static friction, cosine theta, equals the coefficient of static friction multiplied by mass mg. So now we can say that our f is simply, let me just write the denominator first because it's a little bit longer, sine theta plus mu s cosine theta mu s mg. So this will be our solution in terms of, so this is our answer to letter B. And again, this is our answer to letter A. Now, just like in the previous video, this one is, oops, I'm sorry, let me just zoom out so you can see. Again, let me just say that this is your solution to letter B, and this is your solution to letter A. Final answer for letter A and letter B. Okay, how important is this? Sometimes in the multiple choice questions, you don't have enough time to work on the solutions, but instead, if you have this solution handy with you, in terms of having the same setup, you'll be able to come up with the answer right away. Okay, what is the difference between measuring it from x-axis and y-axis? From the previous video, let me just cover it here. If you notice the difference, instead of sine, so instead of cosine theta, change it to sine, and your sine change into cosine. Same thing on your mu sub s. Now, previous video, video number 5, I mentioned something about what if the velocity is the same also. So it's just the same thing, okay? What am I saying? It's the same thing. It's the same solution. Okay? It is the same solution. I just got a piece of paper right here where can I write? So you will be able to see the answer. Oops. Everything, something on it. Okay, so here we go. So again, this is the same solution. This is this exact solution if the initial velocity v naught, okay, let's say it's moving and the velocity is v, and then the final velocity v is also v. Okay, so it means you have the same velocity. Okay, if you have the same velocity, then the acceleration along the x-axis is also 0. And for this problem, the acceleration along the y-axis is also 0. So you will have the same answer. The only difference is change your coefficient of static friction to kinetic friction. Instead of mu sub s, change it to mu sub k. So that is 5 sine theta mg minus f cosine theta. So that will be for letter A. For letter B, so your F, or the amount of force that you can apply to make sure that it stays the same state of motion, is going to be sine theta plus the coefficient of kinetic friction cosine theta, coefficient of kinetic mg. So that will be our numerator. So that's the difference between angles measured along the x-axis or the vertical axis or horizontal axis against angles measured from the vertical axis or the y-axis. Some changes in my background.